the step meshing on this part. Now see how we can apply the step meshing. What is the how first how we can check on which geometry we can apply the step meshing. So in Ansys measure we have that criteria to see which body is a separable body. Separable body means where we can apply the step meshing. So on this complete body we can apply the step meshing. Okay, so this is one of the criteria to check the separable bodies. Okay, so what basically step meshing is? Step meshing is the meshing in which we can make a hexahedral cell and we can make a structure mesh. Okay, hexahedral cell and the structure mesh. So as you all know that hexahedral cell is one of the uh, very useful cell element because it gives a less cell count when we generate the mesh on a complete body. It gives a less cell count as compared to tetrahedral, and it make a structure mesh. Structure mesh means elements will come in a one row. Okay, row. So that's why it is and once we do a calculation in a fluent, when we do a calculation on each cell, it consumes less time. That's why we have already heard that structure mesh is always good in a CFD. Okay, so this complete body is capable. First of all, we'll change this physical preference to CFD. Okay, and solver is fluent because fluent is well known. And based on this solver and safety perspective, we have to make a mesh very much fine. So first we'll insert a method, and we know on this complete body we can use a method. So in the mesh method, once the body is selected, we have a six option. Okay, so we are doing a step method. Okay, in a step method, what we need to give input is very much important. Stepping action, we know that from one how we make us geometry using the step. So this is just similar to that once we select the source and target, we can have a very structured mesh. So source means whatever mesh you will generate on this source, we can have a same thing on a target. So this all called side faces. So in a step meshing, we need a source and we need a target. So once we start a mesh from the source, it will proceed and comes same on a target face. So this Ansys also given a best thing in this part that we can select the source automatically, target automatically, or you can select manual source and manual target. Okay, and manual source. So we'll go with first manual source. I will explain you what is a source. So this is one source and we'll apply it. Okay. So whatever mesh will come on this source, it will be automatically come on this target face. Okay. And this is the number of division that you can apply on the side faces. So right now on this side faces, you can view the number of division like 50. Oh, first we'll go with the less number. Okay, so that we can count it out. Okay, and then generate the mesh. Okay, so you can see this is a swap method. You can see every element is a hexahedral. Okay, it's all hexahedral elements. Okay, everywhere you can have a hexahedral element. Okay, and it is coming in a row like this. So it's a structure mesh, and this is what 20 odd divisions. If you decrease this, if you increase this divisions to 50, we can have a much more lesser cell size on the side faces, and that you can see using this part. So you can see now can decrease. So you can decrease much further more, or else you can decrease the element size to be have much more fine mesh. So see you can see this face, whatever mesh that you have came on this source face, I will zoom it. Same will be there on the target face also. Same thing. Everything is will be similar. You can see same thing will come. on a target rate. Like this cell, you will get over here on the same place. You will also have a same over here. Okay, so that is what a beauty. Once we have similar cell and in the structure mesh, so computer has to do less work in counting, in doing the when it perform solve the matrix. It has to do less work in that because we have similar shape. Okay, and hence it is required less effort to solve the equation. Right now, what else we can do? We can make it this fine, or else you can decrease the element size from here. Right now it's 2.5. We can make it 2 e to power minus 2 for a better refinement. And then we take a skewness. So skewness is the first parameter to check the mesh quality. So in a quality, we check the skewness. So skewness should be always less than 0.95, and if it is less than 0.95, it means the geometry is well defined. Okay, you can see it's a zero point 0.6, and it is very much good. If we have a zero point 0.6 skewness, it very much good, and it's a acceptable range. Less greater than 0.95 is a bad, less than 0.95 is a good. So right now we can just divide this also, and or we can else we can make this also as a structure mesh. Okay, how we can do that? We can go and insert map face meshing. So this face meshing is used to make a face on face a structure mesh. Okay, so once you click on this, and then you can also put a division along this part. Okay, so we can have like around, if we have a 10 division, and then you can generate the mesh. So see, you can have a very much good mesh in this region. Okay, so it's also a structure, and you can see once we have done this, automatically the skewness has been decreased from 0.65 to zero point 0.4, means we have approached in a right way. So you can see this is also a very much structured match. And overall also we have distributed the structure. Earlier in some part we was getting a some waste cell earlier, but right now it's completely turned into the hex cell, which is a good sign. So that every means everywhere we got a good structure mesh. So you can see at every, this is a 10 number of division because we already provide the radial number of division over here, that is 10, and uh, structure mesh. So you can see if I count it, 1 2 3 4 5 6 7 8 9 and 10. This is a 10 cell division, uh, phase division radial in radial direction we have used, and that is possible with the help of phase meshing. And overall geometry is a structure mesh. Again, in this part we can do some edge sizing also. In the edge sizing we can give the number of division that this edge should be divided into the number of divisions, and we can make a fine in middle regions by using a biasing. We can say that yes, in the center part we can have a fine mesh, and at the corners we can have coarse mesh. So that thing also we can check. And as I told that in step meshing, whatever you will do on the source face, it automatically come on the target face. So you can see the target face also same kind of mesh. Okay, nothing changed. Okay, similarly, the we'll go for edge sizing. So we go and select sizing, and then select the edge selection, that this cell should have a good number of division. Will control by not element size, will control by not sphere of influence, will control by number of division. So we can make a 25 odd division. You can see that this size has been again reduced. Okay, and we have identified odd number of division on this both the edges. Okay, and right now if we want at middle section we want fine mesh, and at the corners we want coarse mesh, that also we can do with the help of this option. So if you see this option, it telling that it's fine in center and coarse and coarser at the corners. So we will select this, and then it will ask for how much biasing factor. We can do a good 5 times biasing factor. So you can see at the center we have a fine mesh. As we go along the wall, we have a coarser element. So that also we can control it, and then this is done. Once we have this distribution, we can have a same distribution on circuit also. Okay, so this is what done, and using the a sizing, you have seen that we have again control the hex. Okay, skewness, and now skewness decreased to 0.2, and which is much more better than the earlier scenario, and hence everything is hex, and we have a completely structure mesh, and we can rely on this geometry, and we'll have a very much good results using this method and using this geometry.